So, good day, students of statistics. This is the first section in Unit 3. When we finish Unit 3, we're going to have a midterm. So, just want to emphasize for importance, our goal is always to discuss critical thinking. We want to be able to look at statistical situations and think about them and what they mean. Now, in that case, we want to rely on technology to help us get all the numbers that we need. However, if you do it on technology without an understanding of where those numbers came from and how you could get them without technology, then that can lead to just a misunderstanding. You're just trying to memorize steps on a calculator or computer or a program without really knowing what you're looking for. And so although we want to critical think and we don't want to spend all our time calculating, we need to know how to calculate, and that can guide us into, that can create a guide or a pathway to how to use technology. Okay? To use tech. All right? And so that's a great thing. So in this chapter, we're going to be focused on what are called measures of central tendency. Okay? Which for this particular section. And measures of central tendency look at data and they try to find the middle. Where's the middle? That's the goal. We want to be able to find the middle, and there are different ways to do that. So we're going to name some statistics, all right? And when we name those statistics, they come under a category of what we call descriptive statistics. Why are they descriptive? Because they tell us where things are located, or how they look, or how to find the location of something. And so chapter 3 really is about descriptive statistics. Later on, we're going to do something called inferential statistics, where we make decisions based on the descriptive statistics that we have found. All right? So here we go. Let's talk about what these measures of central tendency are. So there are 4 measures of central tendency: the mean, the median, the mode, and the mid-range. All right? And we want to know how to calculate or find each of these. Not all of these can be found on a calculator, although you can find the mean and the median either by using a calculator or using special menus on a calculator or a computer, and I'll show you that. The other thing we want to do is we want to determine the effect of outliers on the mean and the median. Okay? And so that's our goal. So let's get to that. So number 1, the mean is essentially the average of a set of data. Okay? It's just the average. And so we illustrate this with a formula. We say the mean is equal to the sum of all data divided by the number of data. All right? Or all the data in a data set, let's say that. Now, we can illustrate this a little bit differently. A couple of mathematical notations. The first one is we can say that x bar equals the sum of the x's over n. This is the formula for the sample mean. All right? And we can also say mu equals the sum of the x's over n, capital N. And this is a formula for a population mean. Now, you'll notice that they're essentially the same formula. Now, let's talk about some of the things in this formula really quickly. The symbol for sample mean is x bar. The symbol for population mean is mu. This is very normal, all right? Where we use Greek letters to illustrate data from a population, and then usually regular letters to illustrate data from a sample. This symbol is sigma, Greek letter sigma, and means the sum of. And if you did a lot with sequences and series in algebra or calculus somewhere, then you would have seen this symbol quite a bit. The x's, the individual x's, those are data values from whatever data set we are working on, okay? And then n is the number in the sample, whereas capital N is the number in the population. Okay? In general, what do these formulas tell us? They say add them up and divide by the total. That's what they say. It's pretty straightforward, all right? Now, to find the mean, you have to use all data values in the sample or the population. So you need to use all of them, okay? Means are not resistant, all right? And what's that mean? Extreme values, resistant means extreme values have an effect, all right? Have effect, okay? So suppose I take a bunch of you out of class and I find your average working salary. Now, typical college students in general are mostly working part-time jobs, and so they make a little money here or there. Every once in a while, you'll have an older student or a student who's working a full-time job, so they make a little bit more money. But in general, if I was to find like your average hourly wage or maybe your average yearly wages, in general, most people's numbers would be, fairly close to the same number. Now, suppose one of you happened to be an NBA player on the side. So the minimum salary for an NBA player is like $5 to $10 million, I think. And so what that would mean is if I threw that person's salary, it would actually have quite a large effect because most of the rest of us as college students are, we might make 10 or 20,000 a year doing part-time jobs, maybe a little for full-time work in the summer. But because we're not working full-time day to day, we're not making that much. But if we happen to have an NBA player who is coming to school at the same time and they were taking statistics, they would really make the average higher than it would actually be. Because that $1 million, even if you spread it over, say, the 40 students in our class, it just makes everything a bigger number. And so the mean is not resistant to that kind of change, but other measures of center are. All right. So there are several examples of finding a mean, but it's fairly simple. If I have this following data, say I have 5, 7, 2, 4, and 6, all right? Then if I want to find the mean, I would add these up, and then I would divide by the number of them, all right? And so that would give me 12, 14, and 10 is 24 divided by 5. So the average here would be 4.8, okay? And that would be the mean. So that's a very typical way to do it. Add up all the data, divide by the total number, okay? Very simple process. So the next data is called the median. And to find a median, you have to arrange all your data in order. And the median is the middle value. And so let me put quotes around that. And we'll talk about some of the strange things that happen with the median. First thing is I've got to put this data in order. One of my favorite ways to organize data is just do a stem and leaf. All right, it makes it really easy for me to put data in order. So I see 2, 3, 4, 5, 6, 7. All right, so I got 25, 20, 50, 25, 75, 35, 50, 25, 30, 50, and 45. Now, the data is not quite in order, but I can order it up really quickly. And this is sort of the beauty of using a stem and leaf to get data in order. I can go 0, 5, 5, 5, 0, 5, 5, 0, 0, 0, and then 75. And now I've got the data in order. In fact, if you look, if I write them down, 20, 25, 25, 25, 30, 35, 45, 50, 50, 50, 75. So see, they are all in order. Now, if you count these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So the median is going to be the one in the middle. One way, so basically I have 11, and I just want to cut that in half, which is about 5.5. So I need 5 terms. So 1, 2, 3, 4, 5. And then from the top, 1, 2, 3, 4, 5. And so the exact middle term is 35. So I would say the median equals 35. Okay? Now, This was really nice because I had an odd number of data. Notice I had 11 pieces of data. When you have an odd number of data, it's always the one in the middle, okay? So if I divide 11 by 2, I get 5.5. And so that means 5 data are below, and then the sixth one will be the actual middle, and then I'll have 5 data above. So this is a little math trick I can use to help me find the middle. But what if I had this data, same data, but I was missing one data value? So I'll put them out here in order. And I'll leave out the 75. So now, instead of having an odd number of data, I have an even number of data. So if I cut that, there are 10 of them. If I take 10 divided by 2, that's equal to 5. So I know 1, 2, 3, 4, 5. But then I have 1, 2, 3, 4, 5 below. So there is not one number in the middle, there are 2 numbers in the middle. If that's the case, then you take 30 plus 35 and you divide it by 2, which will be 32 and a half. So this would be considered the median if this was our data instead of the one up there. Okay? Now, the median is resistant. If no matter if you have a big number that would raise the mean, that's just one number in the list. So the median is still going to stay in the middle once you order them. You just have a really large number at the top. And so the median will be much closer to what it would be without that large number. So it's highly resistant to being affected. Okay? It doesn't change, therefore it's resistant. It does not use every data value. Once we put them in order, we're really just focused on what's in the middle, or if there are 2 of them in the middle. Okay? Finally, let's go to the next option, which is the mode. And the mode is the data value that occurs most often. Now we had 20, 25, 25, 25, 30, 35, 45, 50, 50, 50, and 75. Now, that was the data we had from the last problem. Now, when I look at this particular set of data, I have an interesting thing going on. What I notice is that the number 25 shows up 3 times, and so does the number 50. So if that happens, then this would actually have 2 modes, sometimes called bimodal. And the modes are 25 and 50. And so you have to write a sentence. Modes are 25 and 50. So what this tells us is you can have more than one mode, first of all. Okay? Second of all, The mode can also be found not just with numerical, but with qualitative data. In other words, if a particular response to a multiple choice question shows up more than any other, say you have a multiple choice question A, B, C, D, and more people answer C, either because it was correct or they all made the same mistake, that would be considered the mode. So you can do it with qualitative data, whereas the mean and the median are only numerical. And you can have more than one mode or no modes. If all of these appeared one time, then there would be no mode. Okay? All right. Let me see. If you have more than two data values, if you have three or more modes, then the vocabulary is multimodal. Multimodal. Okay. A good example of this would be if you were a shoe manager at a shoe store. What would you order for your shoe store? Well, what you would typically order for men and for women is you would order the most popular shoe size, right? So for men's shoes, you're going to order lots of 10s, 11s, and 11s because that tends to be what most people have for their foot size. However, for women, you're probably going to order lots of 5s and 6s, I think. 6s for sure, maybe 7s too. And so you would tend to focus on the mode because those are the ones that would sell the most. All right? Okay, that's mode. The last measure of central tendency is called the mid-range. And the mid-range has a formula. You take the max value and you add to it the minimum value and you just divide that by 2. And that's really a kind of a great way to get the middle. Just halfway between the maximum and the minimum. All right? A nice property, it uses only the maximum and minimum values. And therefore, it is not resistant. It is very sensitive to extremes because if you had a big maximum or a very small minimum, then it would affect it. Super easy to calculate. It just reinforces the idea that there are lots of ways to find the middle of a data set. Be very clear that the mid-range and the median are not the same, all right? That you calculate them in different ways, even though they're similar, okay? Now, one of the things that they talk about is they talk about round-off rules. So when we start to round off, and your tests will get graded this way, if your data set is like that data set we just had, so 20, 25, 25, that data set. If you were to find the average of that data set, okay, let's say it was like 32.8. Instead of rounding this to 33, which is what typically students would do, you want to round it to one more decimal place than the data. So here's what I mean. All the data comes in 2 numbers, 2 digits, all right? A ones and a tens place. Therefore, when you find the mean or you find the median, you can round this off to one more decimal place. Okay? That's kind of our round off rule. All right? The mode is just whatever value you get. So the mode doesn't round, but all the others can be a decimal. So you do all your rounding to one more decimal place than the given numbers. That's just something to think about. One other point they make is when doing calculations, do not round intermediate values. I don't know if you remember chemistry and physics from high school, but when you did calculator work, one of the challenges in those classes was always significant figures. And because of the significant figures, we often forgot about this, which is never, ever round intermediate values. In other words, here's kind of a common place I used to see it in mathematics. What students would do is they want to do a compound interest problem, okay? Compound interest problem. And compound interest would have a formula like this: A 1 plus R over N to the NT. And so what students would do if this was kind of an unroundable thing, so you might have $1,000 in the account and you have 1 plus an interest rate of 12% quarterly, so every 4 to the NT. Oh, and this would be 4, and say we did it for 10 years, so 4 times 10. So one of the issues is this, this right here. What students would do is they would do 1 plus 0.12 over 4, whatever that was equal to. And in this case, it's going to equal 0.03. So you would put 1.03 here to the 4 times 10 or 40th power. Now, this is an exact value because 0.12 can be divided by 4. What if it wasn't quarterly? What if we did it 7 times a year? That nobody does that, but what if we did it that way, 7 times a year? Well, then this exponent would change to 70. But what would happen here is you get 1.017 blah, blah, blah. You get this repeating decimal. And so what people would do is they would round this value off and put like 1.02 in there. But that's an intermediate value. What you really need to do is keep all the digits on your calculator and learn how to use the answer key when you come back to calculate this kind of expression. So I want to mention that now because it's mentioned in your text. It might be something you read over if you're not paying attention. I think for critical thinking, the key is it's really easy to find the measures of center. You can do these calculations. I'll show you a little bit on the calculator in class. Let's see, what else do they talk about? Oh, think about what kind of sampling methods are used. And if it's not very sound, then the statistics might not be useful, all right, or very useful. So the next thing is we want to talk about what's called a weighted mean. All right, so let me move. And this is sort of in the Beyond the Basics portion of your chapter. It's in the Beyond the Basics. And so I tend to always ask weighted mean questions on exams. But what is a weighted mean? Okay, by definition, a weighted mean is x bar equals the sum of the weight times the data value over the sum of the weights. And so let's talk about this. What do we mean by a weight? Okay, what we're really talking about is a frequency table. So you have a data and you have a frequency, okay? And so right now we'll just do frequency, but everything I'm about to say about frequency also goes for relative frequency. And I'll show you how that works. But so say we had data values 1, 2, 3, 4, 5, and say we had frequencies 2, 5, 10, 6, and 2. All right, something like that. And since this is the data, you want to find the mean. And so what most people would do is they would just add the data, 1 plus 2 plus 3 plus 4 plus 5, and then divide by 5. But the problem with that is the frequency tells us that we actually have n equals 25 pieces of data. So I should actually be dividing by 25 and not 5. Also, the frequency tells us I don't just have 1 1, I actually have 2 1s. And I have 5 2s. And I have 10 3s. And 6 4s. And 2 5s. So the reality is I need to keep track of the frequency of these numbers in some way. And here's what the real weighted mean is. And you go, oh my gosh, I got to add all those numbers. But then you start to look at it and you say, wait a second, multiplication can shorten this. What if I take 1 times 2 plus 2 times 5? Or is 2 times 5 not the same thing as 2 plus 2 plus 2 plus 2 plus 2? Yeah, I forgot a 2 up here. Just noticed it. And then isn't 3 times 10 the same as adding 10 3s? And then plus 4 times 6. And finally plus 5 times 2. And then you divide by 25, the n value. This is called a weighted mean because what you do is you take the data value and you multiply it by how many there are, or its weight. Now, the weight could also be expressed as a relative frequency, so then you'd multiply the data times its relative frequency. And that would also be correct. If this is the case, you're actually finding something called expected value, all right, which is another name for mean, okay? So that's a weighted mean, and so we will talk about that tomorrow, and I will show you how to do all this on a calculator if you kind of want to peek ahead to it. They do have a TI 8384 plus thing you can look at. And we may talk about how we can do some of this on Excel as well, just because that's a popular program. Well, I think that's all I have for you guys at this point. Good luck with the homework. This will all be posted. Talk to you later. Bye.